been a while since I've made a video. I've missed you guys. I'm sure you've missed the videos too. All right, we're going to do the second half of the protein catabolism first. If you recall, you inoculated 6 tubes. There were 2 gelatin, 1 with each bacteria, 2 urea, and 2 of the litmus milk. Now we're going to look for the reactions. Now, for all of these protein catabolism, remember catabolism means to break something down. If you also look at it the sense that it's a hydrolysis reaction, the addition of water, lysing, or breaking things into 2. So if you look on page 101, there's a general hydrolysis reaction here. And this is with just a general peptide or a small protein. Recall that amino acids are the subunits of protein, and they bind together to make peptides, and then those peptides make the longer proteins. So you see on this here we have the addition of water, and if you'll notice when it breaks into its 2 smaller components, that the H and the OH combine or hook onto those 2 new molecules, filling those electron shells. If you look on page 102, it shows you the specific hydrolysis of urea. So urea, if a bacteria has the enzyme urease, then it breaks down urea using a water into ammonia and carbon dioxide. Well, ammonia is basic, so it's going to raise that pH. And if you recall, the tube that you looked at last time, or that you inoculated, was kind of a peach color. Well, if it raises the pH and you have ammonia, then it's going to turn this hot pink color that most of you seem to have in your tubes, okay? For the gelatin, if you think about leaving gelatin at room temperature, if it's warm, it's going to kind of melt. So your gelatin was incubated at 37 degrees, so of course it melted. So everybody's gelatin is going to be a liquid. So what you're going to have to do is put it on ice, and it says for a few minutes. I would like for you to put it on ice for 10 minutes, okay? After that 10 minutes, if it's still a liquid, then that is true hydrolysis of gelatin. If it remains a solid on the ice, then it means that it did not hydrolyze the gelatin, okay, didn't break it down. Now, it says here in your table, on page 104, it has results for gelatin hydrolysis at, you would have done it at 2 days, and then also at 7 days. So we're just going to do the 7 days because you weren't here for 2. So the rest of your tubes I'm going to take out of the incubator and put them in the refrigerator, but I'm going to go ahead and leave the gelatin tubes in the incubator so they have incubated for 7 days, okay? So then once again, you'll have to put it on ice. Some of the things that you may notice, you probably see the green color there. Pseudomonas is very, that's its characteristic, is it turns things green. It puts out that green pigment. So right here you can see the green pigment. Okay, so I definitely see Pseudomonas growing. Now that was for the gelatin. Now for the litmus milk. One of the things about litmus milk, if you recall when we first started, it was kind of that purpley blue color. And some of the different reactions can occur. Here we have it remaining the same color here, but the top of it is green. Now I want to point out that this is Pseudomonas. That doesn't mean that the media turned green because of the reaction. What it is the bacteria itself is putting out a green pigment. So if you took the green away from that, it would actually be clear. So right here you can see that the media down at the bottom is still purple, but the top of it is clear, okay? So that occurs when you have peptonization, okay? So now the proteins have been broken down and you just have little small amino acids in there, so you don't have the cloudiness that you had with the regular milk. So if you didn't see the green there, it would actually look a clear color, okay? Now this one you see right here has some different levels of things going on. So when you look at the litmus milk, you're going to see some different reactions. Some may be pink, some may be white, some may have the peptonization, some may form curds or clumps at the bottom. So just be aware when you look at the litmus milk, you may get several different reactions. This one's clumping at the bottom, but you can also see the clear forming at the top. So just be aware when you look at the litmus milk, once again, you're looking at some different reactions that are possible. This one has several colors in it. So you might have more than one type of thing going on in those. So when you fill out your table on page 104, you can see that litmus milk, it has different things that it's asking for: peptonization, acid, alkaline. Use your atlas when you go to look at results for this, because you may get more than one type of result, okay? And then for the agar, the urea, of course, you're just looking for that pink color. Okay, so that was protein catabolism.